Hello guys, today I'm going to teach you how to work with the encoding compression scheme. We are going to use Huffman compression way, Huffman encoding. We have one example while transmission through network. It's always important to keep data compression rate high so that over the network can be increased using two ways. Either increase the bandwidth of the communication channel or decrease the size of the data to increase the bandwidth utilization. So when we decrease the size of the data, it means that we are going to use the compression. So what kind of compression we have to use so data will not be lost? Lossless data compression algorithm are important in the network, and Huffman encoding scheme can be used for the lossless data compression. We have guys, we have this data that we want to encode data compression in data structure. And if you see over here in the first step of the encoding, build a table containing the following information. How this information comes? Look, we according to this data, we have alphabet A's frequency in this data. Uh, 10 times A is existing in this data, and E exists 15 times in this data, I exists 12 times, X exists 3 times, so that is the frequency. And we are going to use 3-bit code for each letter to represent. And if we multiply 3 bits times the frequency, mean A takes 30 bits, E takes 45 bits, I take 36 bits, and S will take 9 bits. So total consumption, we are going to use total 120 bits. That is quite much. So we want to compress this data into some other form, so we can just use it over the transmission line. Build the Huffman encoding tree. How we are going to use it? Like according to frequency, we have S 3 times, and we have I 12 times. We just sum up these two, and we make one node according to these two, and that is a 15. Then we have another character, and that is E. That frequency is 15, and we add these two nodes together and make one node, and that's 30. And then remaining one is A, and that frequency is 10. We add the last node 10 with the last mid node 30, and the root node will be 40 in this case. By using a Huffman encoding, all the right paths will be value weighted with the 1, whereas all the left paths will be weighted with the 0. And when we just track these paths, we'll make this table. Now this is Huffman encoding table. We have same frequency of all these letters, but what we are going to do, we compress the data. To find out the A, we need what? We have to just go according to this letter, mean frequency. This is A actually, and this A, how we can reach from the root to this A? Just with one path, and that is the bit 0. So we have one bit over here, and to reach E from the root, we have E here, this one. We have to just go through this all the way towards here. So we will use only 2 bits, 1 and 0. And you can write 1 and 0 here, and then respectively I and S. And when we just multiply these consumed bits with the frequency, in 1 into 10, the 10 bits we consume for A, 2 into 15, 30 bits we consume for B, 3 into 12, 36 bits consumed for I, and 3 into 3, 9 bits consumed for the S. And we consume total 85 bits. And if we compare without Huffman encoding, total bits consumed was 120. Total bits after the compression we consume 85, and when we take the difference of 120 and 85, that's 35, and if we take the percentage, we reduce almost 29% of the real weight of the data. That's fantastic encoding scheme. I guess you like this, guys. I hope so you understand very well. Don't forget to subscribe my channel. Thank you so much and take care.